شكرا. صباح الخير. هو انا بالنسبه لي صباح الخير ان هي الساعه 8 الصبح عندي يوم السبت. انا عارفه عندكم افترنون. هبتدي معاكم النهارده ان شاء الله بان انا عايزه اعرف لو كانت ترفعوا ايديكم كده تقولوا لي how many of you like is beginner in the computer vision. Can you just raise your hand?
Looks like everyone is an expert.
طب حلو جدا. طب دي حاجه حلوه.
حد شجاع رفع ايده، برافو مؤمن.
قليل. اوكي سو البلان بتاعتي النهارده ان انا بس هدي introduction للناس اللي ما عندهاش اي فكره what do we mean by computer vision اساسا. بعدين انا هجو deeper a little bit. انا هقول لكم where I started، ايه الكونتريبيوشن بتاعتي اللي انا عملتها during my master and my PhD. I did both of them outside Egypt يعني. وبعدين بعد كده هديكم more application. انا عملت postdoc وبعد كده I was leading the robotics and vision lab in Purdue School of Electrical Engineering for many years. So أنا هقول لكم بالظبط like at least some application عشان تعرفوا قد إيه الثيوري دي ممكن تبقى مهمة جدا في real life ويبقى motivation إن شاء الله for you إن أنتوا تاخدوها يعني as a career وتشوفوا إزاي تطبيقاته كتير قوي في الحياة العملية. وبعد كده ممكن أديكم فكرة عن أنا بعمل إيه دلوقتي في البيزنس أناليتكس والprogram in particular the graduate program اللي I'm the director of it. It is very interesting for you guys. We have some scholarships and it's 12 months STEM curriculum, which means إن هو بيدي للstudents I think about 2 years إن هم يشتغلوا بعد ما يتخرجوا. At least I will give you an introduction in case anyone is interested. And في الآخر عندكم الإيميل وهسيب لكم إيميل بتاعت assistance that you can reach out. So hopefully يعني ده can it should be useful for you. And again هبقى هشرح حبة. انا مش عايزه انا بتكلم طول الوقت. بعد كده احب اسمع اسئله لو انتوا عندكم. بعد كده هديكم more in the application side. بعد كده هقف حبه اشوف لو في عندكم اي استفسارات وبعدين هتكلم اكتر عن management of technology what do we mean by that and then هديكم شويه contacts عشان لو انتوا interested وحابين تقدموا او تعرفوا اكتر ازاي how to move forward. Okay, so this is my plan. So let me share my screen دلوقتي Okay. All right. So this is my official email for you guys. nme5@stmarys-ca.edu. أو طبعا you can reach me على LinkedIn وهقول لكم الإيميل برضو في الآخر. For those who are new للcomputer vision, what do we mean by computer vision? computer vision احنا عايزين we really want the computer ان هو when it sees an image, any image or any video ان هو you behave like what we human do. They can actually understand what's in the image, so understand more about the content of the image, and we take it even a step further and make some kind of analysis and insights about the image. So for example لو احنا ورينا الصورة دي لأي حد حتى لو baby 3 years we will say that هنا في elephant وهنا في maybe guard and somehow like this there is some kind of interaction. Maybe the guard or elephant are really they know each other so they start to understand more. احنا عايزين الكمبيوتر يوصل ان هو ياخد الكونتنت بتاع اي ايمج او فيديو ويفهم مش بس يشوف ويanalyze الداتا دي ويعمل بعد كده some kind of insights and recommendation based on several images and several content. So let me see navigations بتاعتي at the end. Another image for example هنا لو احنا مثلا عندنا صورة زي دي عايزين make sure ان الكمبيوتر لما يشوف الصورة دي ده في computer vision you understand the content. There is a boy, there is a chair, there is the cake and more, even more, that this boy is standing on the chair and he looks like very excited about the cake. You can see this kind of emotions and interactions. So we wanted the computer إن هو visualize or behave like us as a human إن هو يشوف الصور ويقدر إن هو make sense of the content of these images or videos. Okay, is it hard? Well, actually, it is not very hard. It might seem to be hard. Computer vision, for those who are new, بقى advanced قوي after the text categorization. So the text domain or text analysis or pattern recognition, all of those domains were advancing at some point. So we started doing a lot of text recognition, text segmentation, and things like this. بعدين بعد كده we move forward to the computer vision where we try to take an image and try to recognize ايه اللي في images أو segment some of the important objects in the images. But the idea was the same. إن إحنا in order to train a computer or in order to teach a kid about this is an elephant or this is a boy or this is a cat or this is a dog, we need to show them so many objects so that they can actually learn that this object is, for example, a car or a boy. And then they, in real life, humans or kids actually build some kind of models. So what we are trying to do in computer vision is that we try in إحنا to collect a lot of data for any object of interest, a cat or a car or a house or whatever object we are looking at on the future. And this is going to be our input. So we start with data. دلوقتي it's not a problem because we have huge amount of data sources. So مشكلة الداتا is not actually a big deal. We have a lot of big data now. So once we collect a lot of data, and this data actually need to be diverse, like different as much as we can. So I will show you why in the future. So then we try to build a model, and I will dig deeper. What do we mean by model? And then in the future, we hope that when we have a new image or a new video that we did not give it as an input to our model or our system or our computer vision algorithm, the computer will say, okay, this looks like similar to the previous image that I have learned about a cat. So looks like this is a cat with a high probability. So in computer vision, في عندنا mix كبير جدا جدا ما بين statistics because we use a lot of probability to get our final decision. So as I mentioned to you guys, واحنا بنجمع الداتا, we need to make sure إن الداتا بتاعتنا clean and diverse. So for example, I want to say, if I said that I really want to build a model to recognize or to learn any cat object, and I just give it an images for normal cat. So if we show this kind of cat, see body how it is flexible or articulated, we call it like this, it might not know that this is actually a cat because we did not introduce such kind of diversity or examples that shows that cats might actually be articulated or very flexible like this. So we always need to make sure when you collect the data, not only have the data like for a specific pose, we need to make sure that we have different samples for cats which are of color, dark and white and gray, or different shapes like this. So we try to make sure and collect data to be diverse as much as it can. So for example, هنا cat is occluded. Occluded means ان هي نص وشها بس اللي باين. So part of it بس اللي باين. So we need also to collect this kind of examples so that when we have similar images like this that we did not train our model on it, then the model will be able to say, okay, this is actually looks like a partial cat and I have seen examples similar to this. So I can now recognize that this is a cat with a high probability. Again, different collection. أنا عايز أقول لكم إن فعلاً جزء كبير جداً من التريننج بيعتمد على quality of your data. So quality means that you need to make sure that you have enough data and diverse data. Your sample size has to be good enough and your data has to be diverse enough so that the model is trained on all of these different possibilities. علشان later, when it sees a new image, it can easily relate or map it to what it's seen in the future. زي ما قلت لكم دلوقتي, we are on the age of data. We have huge amount of data sources. And now, what we do with this data? Okay, we collected huge amount of data. Okay, إزاي بقى نبني الموديل, الالgorithm, computer vision can make use of, so it can translate these images into a mathematical model, and then later it can actually make use of this model. لو انتوا خدتوا بالكم في image هنا في الأول I skipped it اللي هي بتاعت البوي دي. at the end الimage دي الكمبيوتر عشان يفهمها it has to be translated into numbers or an array of numbers. So all of these numbers actually represent color information. So how dark is this pixel? How light color is this pixel? So this is the information that the computer will see for each image. For every pixel, it will be translated in a number, and this number is going to be mapping the color information or the intensity information of each pixel. So احنا دلوقتي فهمنا ان at the end when we load the image in any software we'll be able to see this image as a matrix of numbers. Okay. First thing when I started computer vision is that I wanted to know, okay, how can I start doing this? I focused mainly on a problem which is the recognition or the classification problem. This is only one problem in computer vision. There are many of them. بس النهارده أنا هركز mainly على recognition سواء object أو scene and also about what's called the features. So I will start by giving you an idea about the bag of visual words model, which is like the standard model for doing recognition tasks. And this model it was mapped or transformed to the computer vision domain from the text recognition. هقول لكم ايه المزايا والعيوب بتاعت الباج of words and ازاي the community was able to overcome the main drawback of the bag of words. And أنا هقول لكم what was my contribution in my PhD. What did I did? And I will speak more about the concept of features. دي حاجة مهمة جدا. What do I mean by this? وإزاي in application this can be useful. وبعدين بعد كده move forward ل hopefully one or two projects that I have been working recently on my research with the Robotic and Vision Lab at Purdue, with the United States Department of Agriculture and the Applied Research Association, which involve dealing with images, but this images is satellite imagery. Okay, so let's take step by step. احنا قلنا في الأول إن احنا to start, we need to have some training data. With this data, let's say دلوقتي أنا عايزة أبني أو أعرف الكمبيوتر على نعمل حاجة زي face recognition. What should we do? Collect a lot of images about different faces, for example. And then we collected the images. What should we do next? The next step is called the feature extraction. So أنا عايزة make sure لما أنا أشوف image بتاعت face of any human, I need to extract important features. Like what? Like, for example, the eyebrows, the shape of the eyebrows of each face. I want to record this as an important feature that can describe and also discriminate one human from another. The shape of the eyes, the shape of the nose, the shape of the mouth, the chin. So every part that I'm trying to mention now, this is what we call an important feature that can help us later to describe the content of the images. And these images are faces in this case. So we try to extract these features and from each image, and then we collect these features together in what's called the bag of features. So how can we actually do this feature extraction? So في algorithms كتير are going to invent the standard ones, which is called the SIFT, Scale Invariant Feature Transform Detector and Descriptor. ده بيخلينا إن إحنا identify important parts in the face, and then later we can collect them into what we call this bag of features. So this is the important thing, the feature extraction. It's lots of many algorithms. Important ones are the SIFT and the HOG, and lots of color also features like the hue and saturation, the value, so many things. So once we started collecting features, we try to cluster this feature, group this feature. So for example, all the eyes that we collected from the different images should be in one cluster. All the different shapes of the noses should be in one cluster. All the different shapes of the eyebrows will be another cluster. So this is what we call the quantization So we try to cluster those features which are similar into cluster. And then for each image that we have in our training data, we try to re-describe it again based on this new cluster. So let's say that we will just say we will create 5 clusters, but in real life, we create like thousands of clusters, but for simplicity, I will just mention 5 for now. Let's say the eyebrows, the eyes, the nose, the chin, or maybe the cheeks, for example. And then we go to each image and see how many times we have seen the first object, how many times we have seen the second feature. So every image at the end will be quantized into a histogram of those visual words. So now we transform the initial image into a histogram. This is a part of statistics, or what we call actually the machine learning and artificial intelligence. So after we describe each image using a histogram of features, visual features, we try to pass this information to a machine learning algorithm. The famous one is called the support vector machine. And based on what I have seen from the audience, I think now everyone should know about it. So what we do now is that we pass all these learned histograms from the training images to the support vector machine, which is trying to say, okay, all those histograms, I know that they are representing humans. So I will keep this into my memory. So later on, when I have a new image and is represented into the histogram visual words, what will happen? It will try to measure the distance between this new histogram, like this image here in the bottom, and what was built in the memory of the support vector machine, which we call the model, the statistical model. And if the distance is, between the new histogram and the model, we measure the distance, is maybe higher than a particular threshold, we say that there is a high probability that this new image is actually a face. If it is not close enough, then we say that this is actually another object. So this is how the bag of words, or the bag of visual words model, which is a very standard model in computer vision, works to train the model on any object of interest. And if we have a new image that we did not see in our training phase, it can actually let us know whether this image is belonging to our model or not. Okay, looks like this is, this was a simple model. So this is one of the very important things about the bag of features. Again, it was very successful in text recognition. So it was also successful in computer vision. But as you see, it has one main major drawback, which is once we collect, let's say this is the face of this woman here on the left, and this is the bag of features, visual features of hair. The main problem is that this bag of features does not keep the important spatial information or location information. So it says in this image, there is an eye, there is a chin, there is a mouth, there is another eye, but the location that the eyes are always, and the eyebrows on the top part of any face, and then the nose is in the middle, and then the mouth is in the bottom. This important information, which we call the local information or the spatial information, is completely ignored and missing. And this will actually affect the quality of your model and the quality of your recognition task. So what happened later is that we tried as a community to preserve the spatial information. So the idea of the spatial pyramid was introduced. And this is where I started actually contributing to this domain. So the spatial pyramid first, when it was introduced, it says, okay, we always describe each image using a histogram of features. Okay, but we know that this has a major drawback, which is the lack of the important location information. Why don't we divide our image into quadrats? And then we try to describe, instead of the image, every portion of the image. So we described first what we call level 0, which is the image itself. So if we have 5 features, we have a histogram of length 5. And then in level 2, we divide the image into 4 portions. And then again, we go to the top left corner and we described here how many times we have each of the 5 features. So probably the eye and the eyebrows will count once here. And then we go into the top right portion and we again build another histogram. And then probably there will be another eye and eyebrows. So it will capture this information here that the eyes are on the top. And then we build another histogram for the bottom left. And then we here will probably have the histogram capture that the mouth and the chin are partially in this part. And we build another histogram on the bottom right. As you can see here, we were able to capture the spatial information of the features of interest. But as you can also see that the dimension of the histogram increased significantly. So instead of having only 5 features, now we have 5 times 5, because we have 5 here, 5 here, 5 here, 5 here, 5 here, and then we concatenate all those histograms into one final histogram and then input to our support vector machine. So yes, the accuracy or the spatial information was guaranteed, and yes, the accuracy improved, but the drawback is that the computation is also increased. And this is not always recommended or needed in some applications. So this is one of the drawbacks that I was working on in my PhD. And one thing that I want to mention is that it was also proved that the more you go deeper, so if you take this portion, this square, and again, you divided it into 4, the more you go into a finer representation, the performance of your model will increase. But again, the cost will be that the dimension will also increase, because you will have here 16 portions plus 4 plus 1, so you will end up by having 25 portions that you need to describe, and each of them in the simplest case here is with 5. So you will see that this will actually add up with a huge representation at the end. Okay, so I started my PhD when the spatial pyramid was just introduced. That was, I don't know, 2007, something like this, a long time ago. And I noticed that, okay, if there is a way that we can represent our spatial information and we also maintain in a smart way, and we maintain the recognition, so how can we preserve the spatial information in a decent way, in a more compact way? And that's why the talk of today is called the compact. How can I make it more compact? So I reduce this high dimensionality, but I also have a constraint that I want to maintain the same high accuracy or close to it that I started with. The other problem that I have noticed is that always the spatial information, which was proposed initially, was assuming that all the objects or all the scenes will need this kind of the same spatial configuration. And this assumption was actually very weird, because when I started to deal with more data sets with various objects, I found that this spatial information will be good for some objects, but not for all of them. Like, for example, if we are looking at airplanes, why I need to keep all of those subdivisions? I know that most of the airplanes will be flying, so probably the airplane information will be on the top or maybe in the middle, and the rest will be a sky. So this kind of rigid subdivisions might not be the best for each category. And the same thing for farms or cows here. Most of the objects were always on the middle of the scene. And then at the end, there is a sky or there is a grass. So this kind of very rigid fixed transformation, first is high dimensional. Second, I was here having the hypothesis that it might not be the best for every object. So why don't we learn a smarter spatial representation? And again, while I was working, I also, at that moment, I paid a lot of attention into the features. At this moment, there was a lot of hype on the SIFT descriptor, which captures the shape informations, and the color descriptors, but not so much work was actually preserving the important texture information which later was proved to be very, very crucial for a specific category, especially if we are doing what's called the scene recognition. Okay, so what I did. So first of all, and this is a lesson that I wanted to translate to you or transfer to you, especially if you are in early career in computer vision or any actually research problem, is that make use of other domains that are already advanced. So the text recognition was at this moment really proceeding and start much earlier than computer vision. The information theory was also very advanced. So what I did here is that I said, okay, let's study the literature of the information theory and see if there is a way that I can maintain the initial content, initial information that I already captured in my spatial pyramid, and figure out how can I reduce it so that I preserve the information content. So this is actually the field of information theory, not computer vision. In information theory, you will learn about a lot of algorithms. Some of them is actually, we all learn about them, like the partial least square, the principal component analysis, the agglomerative information bottleneck algorithms. All of those algorithms are very famous algorithms in information theory. What do we mean by this? We want to make sure that if there is any redundant information, we just get rid of it because it doesn't add any value. So we use information theory, in particular, the partial square to reduce these dimensions or to reduce the content of information that doesn't add a lot of value because it is redundant. So what I did is that I take my initial content, which is the original spatial pyramid, which is very high dimension, and I try to apply techniques like principal component analysis or partial least square or the agglomerative information theory in order to figure out what of those features are redundant across my pyramid, such that if I take it out of the pyramid, I will still have the original information preserved and the accuracy is not influenced a lot, but the information of the spatial information is more compact. So this is was my first contribution. So what I did is that I took two different data sets. So I proved my concept not only on one data set. We need to do one experiment and then you need to make sure that it is generalized also. So I take one data set and I started by a big histogram, not big enough, maybe like a 5,000 vocabulary. 5,000 times 21 is the initial size of my initial histogram, and try to compress it using information theory and the dimensionality reduction algorithm, which is very standard. Like partially square here, this is the black, and the PCA is the green. And this is the divisive information theoretic clustering. At that moment, it was the state of the art in the information theory, and it's used a lot in the text categorization. So I tried to use it. And I have seen that this algorithm was able to maintain the accuracy. So here, the vertical part is the precision, and the horizontal part is how much I am actually trying to compress my initial pyramid. So I went to as small pyramid as 50. And I was starting with a pyramid of thousands and thousands of dimensionality. And I found that some algorithms, like the agglomerative information bottleneck theory and the divisive information theoretic clustering, which was at this moment used in the text categorization domain, was able or allowed me to reduce the dimension and the precision, like significantly. And the precision was almost as what I started with. So I was able to make use of the spatial information using a compact representation, and this compact representation allowed me to discriminate between the different classes. That's why I call it discriminative, that preserve almost the same accuracy as what I start with. And I proved it. I take another data set, and then I did the same experiment. I found that the pattern is happening. So this was my first contribution. and this was published in the Pattern Recognition Journal in 2012. Later, actually, in this summer, I believe, the Pascal challenge was just introduced. If you guys new to the computer vision, the Pascal challenge is an object recognition and segmentation and detection challenge. Like, it's worldwide. They give us like 20 different classes or objects, and they ask us to classify, this was one challenge, or detect object of interest, or segment object of interest. My scope was mainly on recognition. So we took this model that I actually introduced, and this was one of the models that allows our lab, the Vision Lab in Universitat Autónoma de Barcelona, the School of Engineering, to win the second place worldwide. Not the only algorithm, but was one of the algorithms. The second contribution, maybe take a pause here. Okay, any questions so far?
I think I have a question, but it's better to say it أحسن مكتوب في الchat. But can you share the slides? It's two slides back related to the compression size. أنا بصراحة اتلخبطت في relation بين ال compression وال redundancy. Is compression the same as like removing redundancy?
Yes.
ومش فاهمة قوي ال x axis ماشي هنا ازاي يعني لما يبقى عندنا compression size كبير يعني ده معناه ايه وليه ماشيين عشان بس هو ماشي العكس فانا اتلخبطت.
صح، ده سؤال حلو جدا. First of all احنا دايما مش عاوزين ان احنا يكون عندنا high dimension. الهاي dimension دي معناها ان انت عندك more complex representation, بياخد more time، صح؟ So the more that you have a longer representation, this means that your algorithm will take a longer time to train and is actually more complex. Just give me a second. Okay. Present again. Okay. So الهدف بتاعنا ان احنا يبقى عندنا representation that actually have a smaller size. So it is actually faster and more efficient. So ال x-axis هنا بيقول لك احنا let's start with a dimension, let's say 500. ده كبير. انا الجول بتاعي ان انا عايزه اخليه more efficient, more compact عشان يبقى اسرع، عشان يبقى applicable in other applications اللي عشان عندها الامكانيه ان هي تبقى عندها high dimension، ان هي تقدر ان هي تعمل computation with this high representation. So الجول بتاعي في الاكس axis ان انا اشوف قد ايه ممكن اصغر representation as much as I can. This is my goal in my x-axis. فلو أنا قدرت أصغر representation بتاعتي أو dimension بتاعتي لحاجة صغيرة جدا، بس in the same time accuracy بتاعتي y-axis هو accuracy. So accuracy بتاعتي مش بتتأثر، أو لو اتأثرت يبقى في تأثير بسيط. So I always wanted my y-axis to be as high as possible. وعايزة دايما الجول بتاعي إن x-axis تبقى as small as possible. علشان كده الاكس اكس هتلاقي الدايمنشن بتبتدي من حاجه كبيره لحاجه صغيره قوي. انا عايزه ان انا اوصل ل اكس اكسس يكون الدايمنشن بتاعي او الريبريزنتيشن بتاعي السايز بتاعه صغير، بس في نفس الوقت انا عايزه الواي اكسس البريسيجن او الاكيورسي بتاعتي تكون مش متاثره. فانا ابتديت هنا مثلا ب 85% وكان الدايمنشن بتاعتي 500 or 5000 whatever it is، وقدرت ان انا اصغر الدايمنشن ل only 50 visual words، وكانت البريسيجن almost like 84%. ف this was a major contribution ان انا اقدر اصغر قوي الريبريزنتيشن بتاعتي، في نفس الوقت الاكيورسي بتاعتي تفضل as close as what I was starting with thousands and thousands of dimensions. كده جاوبت على سؤالك؟
Yes, thank you.
Do you have more questions? Atif? Okay, you can speak up. I'll ask. Okay, after unmute. ممكن تعمل اميوت او
ازيك يا دكتور؟ حضرتك سامعاني كده؟
هي سامعاك بس هي دكتور نهى.
انا سامعاك sorry I was muted sorry.
اوكي،
انا
هو انا
سامعاك.
كنت جربت اشتغلت على البروجكت بالكمبيوتر فيجن، ان انا الجراديويشن بروجكت بتاعي السنه دي على الكمبيوتر فيجن بنعمل ريكوجنيشن لاوبجكتس في اكس راي ايمجز. الموضوع ده كنا عملناه بكونفوليوشن نيورال نتوركس ومع تنسور فلو موديل. انا بس ما عداش عليا الديفينيشن بتاع السبيشال بيراميدز قبل كده في حته، فانا كنت بسأل حضرتك هل دي حاجه مختلفه عن السي ان ان ولا ده جزء من المراحل اللي بعملها في خلال السي ان ان؟
اوكي، ده سؤال حلو جدا يا علاء. بص، دلوقتي الترند بتاع التنسر فلو والنيورال نتورك you don't need to learn your own features. You don't need to design your own features. This is actually one of the beauty of neural network. ان انت you just throw data and النيورال نتورك هي خلال المراحل بتاعتها بتحاول ان هي تكستراكت الفيتشرز دي ليك. صح؟ ده اللي بيحصل لك. الفيس ده كله we call it the black box when we deal with neural network and TensorFlow and things like this. وبتقدر ان هي extract this information, this spatial information actually behind the scene for you. فانت مش بتبقى شايف البارت ده طالما انت بتستخدم النيورال نتورك. بس ليها مشكله بقى النيورال نتورك ان انت مش بتبقى عارف لما تبقى عندك هاي بيرفورمانس هو ليه الهاي بيرفورمانس ده حصل، هي انهي فيتشرز بالظبط هو استخدمها. صح؟ دي مشكلة النيورال نتورك والتنسر فلو، ان انت always you have a lot of high performance because it does this behind the scene for you. It's the black box for you. This is actually what's happening behind the scene. But if you want to know exactly why this happened or to interpret the results, it's very hard. Okay? ومش كل الابلكيشنز في الدنيا بتبقى انت بس عاوز high accuracy. انت في الريل ابلكيشن لما انا دلوقتي هموف للشغل بتاعي الابلايد بتاع بردو we don't care about the accuracy that much. We care about why or what features we designed عشان تدينا high accuracy عشان نقدر احنا بنفسنا نطور الموديل. فاهم؟ it really depends on the application. لو هي الابلكيشن انت بتشتغل فيها you don't really care about justifying the high accuracy بتاعتك, so that's fine. This can work. But some other applications انا هوريكم real example دلوقتي انا اشتغلت فيه. لما كنت بشتغل في بروجكت مع Department of Agriculture هنا في امريكا, كنا لازم نعرف انهي features مستخدمينها عشان عايزين نعرف ايه مشاكلها عشان نعرف ازاي نحلها. فما كانش ينفع ان انا استخدم system زي neural network just through some data and it build a model and then later give me a high accuracy. لا, انا عايزه اعرف كويس قوي ايه هي الفيتشرز دي عشان اعرف ايه عيوبها واعرف اعمل بنش مارك لنفسي, اعرف بالظبط الفيتشر دي ادتني كذا وكان مشاكلها كذا, وعشان اصلح المشكله دي انا لازم اصلح دي في الفيتشر دي او اديزاين الفيتشر دي من الاول عشان تديني اللي انا محتاجاه عشان اقدر ان انا ابيلد الموديل. عشان at the end let me give you an introduction. This project كان عباره عن ان Department of Agriculture هنا قلنا في بردو في الروبوتيك اند فيجن لاب وقالوا لنا احنا عايزين نعمل اوتوميشن للبروسيس بتاعه البرونينج. برونينج معناها في الزراعه يعني لو احنا كنا بنشتغل بالظبط في الابل اورشاردز مع فور اكزامبل محاصيل الابل, كل سنه علشان الانتاجيه تزيد لازم في الشتاء لما يكون الابل تريز ما فيهاش ليفز خالص لازم يعملوا تريمينج, يقصوا البرانشز بشكل معين بحيث ان التريز ما تبقاش عندها ديسيزز وفي نفس الوقت الانتاجيه بتزيد. فكانوا طالبين مننا ان احنا نشوف ازاي ممكن نساعدهم ان احنا الروبوتيك اند فيجن لاب ان احنا ممكن ازاي نخلي البروسيس دي تبقى اوتوميتد. فاحنا كنا عايزين نعمل ايه, وانا هوريكم السلايدز بس خليني اتكلم الاول كده في فريندلي تشات. كنا اول حاجه عايزين نعملها ان احنا نكولكت داتا عن التريز, عن الشجر, نشوف الشجر ده شكله عامل ازاي بحيث ان هي دي هتكون الداتا بتاعتنا. فاحنا كنا اول حاجه رحنا اخذنا السنسورز بتاعتنا different type of sensors lidar او كينكت whatever هنعمل بيها سكاننج للتريز عشان نكولكت الداتا. رحنا للمزارع بتاعت الابل سواء في انديانا او في مكان تاني زي بنسلفانيا، لان التريز هنا بتاعت الابل شكلها مختلف عن التريز هناك. بس زي ما قلت في الاول it's very important ان الداتا عندكم تبقى دايما مكتمله، لان انت لو في التريز متخيل شكلها هيبقى the same بس في الحقيقه لا، يبقى انت لازم تميك شور ان الداتا بتاعتك بتكابتشر كل different possible options. المهم رحنا we did scanning, we collected the trees information from different sites and then we built our 3D model. So واحنا بنتعامل مع البروجكت ده الداتا بتاعتنا كانت مختلفه، فكنا لازم نميك شور ان احنا نديزاين الفيتشرز بتاعتنا بشكل مختلف. فما كانش ينفع في الكيس دي بالاخص ان احنا نستخدم نيورال نتورك at all because it's very applied. احنا بنعمل كل حاجه من السكراتش. احنا we had to design our own features, so later on when we build our own simulators and we get our own robot it know ان هي accurate بشكل كبير جدا، علشان اي mistake في the robotic operation will be a big deal, right? So اللي انت عملته ده looks like the application بتاعتك you didn't need or didn't care too much about designing your own features. It was good for you ان انت يبقى عندك for example detection with a high accuracy. But in real life مش ده دايما اللي بيحصل، خصوصا لو بتشتغل في application. هقول لك مثال تاني برضو. احنا we had to design our own application. احنا كنا شغالين في project بناخد image من الساتلايت maybe يعني ده يكون close شويه لحالتك اكتر. فاحنا كنا بناخد كان project جاينا عندنا query. الquery دي could be an image or video، والquery دي الايمج فيديو متاخده من satellite image. First of all هي very huge, it's very big. تاني حاجه resolution كان terrible. I'm not sure if لو حد فيكم اتعامل مع satellite imagery it's different totally from any other images اللي انتوا تكونوا اتعاملتوا معاها في حياتكم. فالمفروض ان احنا كنا عاوزين ناخد الايمج او الفيديو دي والمفروض نقول لهم roughly like with maybe 70% accuracy فين اللوكيشن بتاع الايمج or فين اللوكيشن بتاع الفيديو ده اتاخدت فين. فاللي احنا عايزين اول حاجه challenges ان احنا عايزين نعملها ان احنا ازاي نتعامل مع image. اولا satellite image huge amount of data. تاني حاجه resolution بتاعت الimage very very low. If we just take this image and throw it to any neural network or TensorFlow algorithm, nothing will be got out from this. It's a very different application. So we actually wanted to dig deeper by ourselves and know exactly what kind of objects we are looking for. هنستخدمه كأن هو landmark علشان يبقى هو الفيتشرز بتاعتنا. انت يخلينا for example لو احنا بنبص على trees نقول الشجر ده for example ده مش بيكون في امريكا، ده مثلا بيكون في الميدل ايست. probably we narrowed it out to a continent. Okay, ال particular trees دي غالبا بتكون مثلا موجودة في مصر أو في الأردن. فإحنا we narrowed even the region even smaller and smaller, things like this. وبعدين for example let's say إن إحنا هنستخدم الرود أو إحنا استخدمنا برضو التريز واستخدمنا الرود واستخدمنا التاورز. لسه أنا هديك مثال مثلا عن الرود. الرود دوت every road في الساتلايت imagery بيكون feature وبيكون using حاجه اسمها الاوبن ستريت ماب. معروف اللاتيتيود واللونجيتيود بتاعته، فانت لو حددت الطريق تقدر تعرف كويس قوي هو فين. فلو انت قدرت من الساتلايت ايمجز دي تحدد طريق تقدر تقول ان we can even narrow it down because we know the latitude and longitude. فعشان نحدد الطريق احنا كنا محتاجين نشوف feature to describe اي طريق. فاي feature اي طريق يعني في امريكا مثلا بيكون في كروس ووكس، انت بتعدي كده بيبقى في دايما اللي هي الكروس ووكس اللي هي العلامات اللي انت بتقول لك عدي من هنا. فاحنا we had to design a feature to describe او to detect crosswalks. احنا استخدمنا for example Fourier transform اللي احنا بناخدها دايما في الفيزيكس والحاجات دي عشان نقدر نشوف اذا كنا ممكن نحدد الكروسوالكس ولا لا. واحنا we had to design our own features. So lesson learned from this is that not all the applications can use neural network علشان انت بتبقى محتاج information علشان تساعدك عشان تعرف انت فين بالظبط، او محتاج features النيورال نتورك مش تقدر ان هي تستخرجها لك، او محتاج ان انت تعرف بالظبط الفيتشر دي هي ايه واديت لك performance ايه، ولو هو وحش ازاي تحسنه. فدي يعني like experience كده package from what I have seen يعني.
ميرسي قوي يا دكتور. انا كنت بس اقول حاجه اخيره. انا فهمت من حضرتك ان ده معناه ان الموضوع بيبقى specified by the project او الابلكيشن اللي انا عايز اعملها. ده معناه ان انا في الشركه لما بيجي بروجكت وقتها ببص عليه وافكر انهي ميثود هتبعها، ولا بيبقى البوزيشن عباره عن ان انا في الشغل هبقى بشتغل مثلا في السي ان انز وابقى اخد البروجكتس اللي تناسبني وبس، ولا بشتغل في السكه بتاعت السبيشال بيراميدز والسكه بتاعت السي ان انز، وعلى حسب البروجكت اللي جاي يختار هتبع انهي ميثود فيهم؟
ده تمام، ده تمام. انت لما بيجي لك بروجكت لو انت عارف حاجات كتيره ده بيساعدك انت في ان انت تقول اوكي انا هجرب ده وهجرب ده. لو انت you know if you know both because you know both of them you can actually boost your performance. بس دلوقتي طبعا نتيجه ان اللايبرز الكتيره اللي بقت open source بقت an easy way for everyone ان هو يجو with a neural network at least as a starting point ويشوف هيوصله لايه. بس في الريل لايف احنا مثلا لما جينا نيو بروجكت او بروجكت كبير اللي احنا بنعمله ان احنا دايما بنمشي في التو باثز مع بعض. ان احنا بنشوف لو احنا if we designed our new features احنا عارفين عن اللونج تيرم ده السوليوشن اللي هيبقى unique to us ويخلينا ان احنا نقدر نعرف مشاكلنا ونقدر نحسنها، بس ده بياخد وقت اطول. وفي نفس الوقت بنعمل باث تاني ان احنا بنشوف اذا كان النيورال نتورك والتنسر فلو كان بي a venue or not، وبنشوف ايه اخره بمعنى اصح لو احنا استخدمناه هيدينا results عامله ازاي. At the end it might be great to merge both of them but الطريق الاسهل والاسرع في الاول at least to give you an insight about where are you هو انت بتستخدم النيورال نتورك والتنسر فلو لان هو سهل استخدامه بتشوف results very very easy. بس اللونج تيرم الحاجه اللي بتبقى بتخليك فعلا تعرف مشاكلك وعيوبك وكل الحاجات دي وتحسنها ازاي و to propose something different و unique هو ان انت تفكر outside of the box ان انت to design your own features. بس لازم يكون عندك النو هاو تكون عارف ده وعارف ده.
Okay, Doctor. I think they were very fruitful questions and fruitful discussion. I think we can يعني نكمل في الcontent وبعدين ناخد اللايف questions at the end.
طيب ماشي كده.
About that. Okay.
تمام. Okay. Let me move forward. Okay. تاني حاجة عايزة أتكلم فيها هو أهمية الفيتشرز. وانا لما ابتديت زيكم كده في الكمبيوتر فيجن كان عندي مشكله كبيره قوي ان انا نفسي قوي افهم ايه هي الفيتشرز دي. هي حاجه معنويه يعني حاجه عمرها ما بتتشاف صح. ف بدات افهمها قوي من موضوع الفيس ريكوجنيشن ان انا احاول ان انا اطبق او اشوف فور اكزامبل انا بستخدم زي السيفت او الهوج دول two very important detectors and descriptors بيحددوا لنا الفيتشرز اللي في الفيس او اللي في الهاوس او في اي object of interest وكانوا مشهورين جدا وكانوا بيحققوا هو السيت of the art at this moment. وبعدين بعدها على طول جه الكالر انفورميشن الكيو بتاعت استخدام الكالر ان هو يبقى ديتكتور او ديسكريبتور مهم جدا. واللاب اللي كان بيشتغل جامد قوي في الموضوع ده كان University of Amsterdam School of Engineering الفيجن لاب كانوا فعلا very advanced ان هم استخدموا and they also introduced new color features. But what I have seen based on my survey at this moment is that my problem was mainly on recognition سواء كنت بستعمل scene recognition or object recognition. When I worked with the scene recognition كنت عندي scenes for example to differentiate whether this image is a forest or a river or things like this. أنا لقيت إن مش بس الshapes important. I found that if you look at this image you will find that there are pattern. Trees has pattern and this pattern is actually repeated over and over and over. But the shape information only they care about the edges of any object. So I said, okay, this information looks very obvious by me, like visually when I look at this image, for example. But how can I describe it in computer vision? In computer vision, في different or category of features called the texture features. لو أنت مثلا عندك tiger أو عندك lion جسمه في pattern هو الفيل dots دي مثلا بتتكرر over and over ده اسمه التكستشر. So I started to survey not so many people who are actually working on the texture descriptor طبعا كان في state of the art like the Geber, like the local binary pattern. These are like so standard in this point. لكن ما كانش موجود ساعتها texture descriptor. حتى local binary pattern, if you guys don't know about it you should hear about it. كان very new and it was also very famous عشان ال computational expense. يعني كان سهل قوي ان انت يعني بياخد very less time to compute the texture information. بس ما كانش also preserve location information. So what I said is that okay, let's combine the strengths of this a new texture descriptor اللي هو اسمه local binary pattern وعملوا منه many objects to capture a lot of illumination changes and things like this. تغيرات في الإضاءة يقدر إن هو يبقى less sensitive ليها. وأقدر إن أنا أشوف لو أنا دمجته مع أو قدرت إن أنا أدخل فيه حتة الspatial information هل ده هيساعدني في إن أنا أحسن البرفورمانس بتاعة الموديل بتاعتي ولا لأ. فاللي حصل ان انا اخدت نفس الداتا سيتس اللي انا كنت مستخدماها قبل كده كانوا scene recognition data set. Again زي ما انتم شايفين when I'm proving my theory I never rely on one data set. At least you have two. And then later for Pascal I also use it on a very larger scale. So أنا قلت ساعتها كان المين state of the art descriptors Geber the local binary pattern بجميع أشكاله وألوانه. كان في كذا واحد من اللاب بتاع فرنسا. I think many other labs in RIA. If you need to know about this lab, it's really very famous and they put a lot of open source code outside. And I tried to combine the local binary pattern with a lot of color information and then see if this information combining the texture with the color can boost the performance. لما أنا كنت بستخدمها الجيبر اللي هو كان the best of the best at this moment اداني 66% accuracy for my data set which is called Olivia and Toralbach. It's very famous in scene recognition. When I tried to use a different version of the local binary pattern, the best I had was 83%. And when I tried to combine features like the texture and the color, I found that this was an improvement because the accuracy of my model increased to 85%. When I tried called the pyramid, when I tried to combine the spatial information into the color texture descriptor, which I come up with, the state of the art result was actually achieved, which is 87%. So again, that برضو بيأكد لك على in some applications you actually need to at this moment ما كانش في neural network ولا TensorFlow, and we needed to explain when we use the Pascal challenge when you contribute in these big challenges, they wanted to know why your model is working. So in this case, we can justify with these numbers that we come up with something new. We designed a new feature that's not the sift, that's not the shape, that's not the color. It's a mix between the texture and the color and the spatial information. And this is why we were able to take the second place worldwide. And this work was published in the Image and Vision Computing Journal a year after, 2012. A year after the compact contribution that we did on this lab. Okay, أنا عايزة في last part أروح معاكم للأبليكيشن بتاعة بودو. دي أنا كنت بتكلم معاها سريعا مع علاء لما كنت أجاوب له سؤاله. Again, إحنا when I finished my PhD, I moved to Amsterdam. I worked a lot in a project mainly on the color. Just to give you a brief introduction. انتوا لما بتاخدوا أي صورة ليكوا انتوا شخصيا جوه البيت أو بره البيت أو بالليل أو الصبح، بتلاقوا إن الصورة دي مختلفة، الإضاءة مختلفة، فبالتالي الصورة مختلفة، فبالتالي الكمبيوتر صعب قوي إن هو يقول إن الصورة دي هو أنت، صح؟ ودلوقتي الكاميرات الجديدة بتحاول إن هي تحل المشكلة دي. فلما أنا رحت آخر فيز في البي اتش دي في أمستردام كان مين إن أنا بشتغل على حاجة اسمها color constancy. how إن أنا أخلي الكمبيوتر يعرف إن الصورة المتاخدة لنفس الأوبجكت في أماكن فيها إضاءة مختلفة دي هي نفس الأوبجكت، بس أنا محتاج أعمل correction الإضاءة. لو انا عملت كوركشن اضاءه فالصوره كانها متاخده في نفس الاضاءه، ده هيقدر يخلي الكمبيوتر ما يحصلوش confusion، ويقدر يخلي الالجوريثم بتاعي more robust للillumination changes. ده كان اخر شغل، انا مش هتكلم عليه كتير النهارده عشان عايزه go into the application side. ده اسمه في الكمبيوتر فيجن color constancy. The University of Amsterdam, in particular School of Engineering, the Vision Lab, very advanced on this. And this was my last work on my PhD, and it was published in the transaction of IEEE of image processing. بعد ما خلصت ده, I went to Purdue to make my postdoc, and then I worked after that as a research scientist with them after I finished my postdoc. So البروجكت اللي انا هتكلم عليه هو اول بروجكت انا اشتغلت فيه and it's still an ongoing work. When the United States Department of Agriculture had the challenge ان هم كل سنه محتاجين يعملوا pruning للابل trees، ولازم تكون بتتعمل بشكل معين، ولازم تكون بتتعمل في وقت معين، لازم تكون في الشتاء والتريز ما فيهاش اي ليفز، وتتعمل بشكل معين بس اللي يعرفها هم الفلاحين اللي بيشتغلوا في الدومين ده، او الدومين اكسبرت اللي هم الفاكولتي ممبرز اللي بيشتغلوا في الاجريكلتشر. فده كان بروجكت مشترك ما بين انجينيرز وما بين اجريكلتشرز وما بين فارمرز، بحيث ان احنا نقدر نوتوميت عمليه البرونينج، مش علشان نتخلص من الفارمرز، بالعكس علشان نساعدهم، لان الشغلانه دي دايما كانت بتحصل بس في الشتاء، وكانوا بيعتمدوا هنا في امريكا عليها على فارمرز بيبقوا دايما immigrant، فاس لايك حظ، ممكن يجيبوا عدد كبير في سنه، ممكن ما يقدروش يجيبوا حد خالص، فبالتالي اللي بيحصل ان جزء كتير جدا من المحاصيل كان بيضيع، وشجر كان بيعيا وبيموت، فكان يعني دامج كبير للكل. فبالتالي لو احنا قدرنا نستخدم تكنولوجيا لايك كمبيوتر فيجن وروبوتكس الاثنين مع بعض واي اي، بحيث ان احنا نساعد ان احنا نوتوميت البروسيس دي يوزنج كمبيوتر فيجن، نعمل موديل، ويقدر الروبوت بعد كده يتعامل مع الموديل دي، وان هو يجو للاماكن الصح بالظبط اللي احنا هنتعلمها بالكمبيوتر فيجن وبالدومين اكسبرتس، ويقدر ان هو يساعد في عمليه البرونينج دي، يبقى احنا كده ساعدنا. ودلوقتي طبعا في الزمن اللي احنا فيه الكوفيد 19 والبانديميك، مش عايزه اقول ان طبعا صعب جدا دلوقتي ان الناس تشتغل وتتعامل مع بعض، وان احنا نجيب immigrants، فحاجه زي كده ثبتت يعني على اللونج تيرم ان هي لازم تبقى يعني نinvest فيها مور، لان هي فعلا مفيده من حاجات كثيره حتى كانت beyond our information when we started this project. As I mentioned, ده project ملوش data, so we had to come up with the data collection. and الداتا دي احنا لازم نروح ونجمع data من orchards. فاحنا كنا محتاجين نعرف احنا هنصور الداتا دي ازاي. اول حاجه انهي سنسور هنستخدمه. كان في اوبشنز كتيره جدا، فاحنا حاولنا نعمل examinations وانا هقول لكم ازاي. بعدين بعد ما نجمع الداتا ازاي نبني كمبيوتر فيجن موديل، وازاي نميك شور ان احنا نايدنتيفاي البرونينج بوينتس دي صح، لان انت لو عملتها غلط ممكن تقتل الشجره او تهرت المحصول اصلا، شجره تموت. وبعدين بعد ما نعمل الموديل ازاي نميك شور ان الريزلتس دي accurate، فلازم نبني visualization tools وsimulations علشان اول حاجه نشير النولج دي مع الدومين اكسبرتس يفيريفاي ان احنا بنعمله صح، واحنا كمان تبقى بالنسبه لنا tool for debugging، بس when we show visually that this is the points and we can actually improve. And it was actually a transition ما بين visualization or computer vision والروبوتس. So محتاجين في النص نعمل زي simulation، ومحتاجين نشوف الريزلتس، ومحتاجين نشوف الروبوت ارم هتيجي فعلا على البوينت دي ولا لا. فكان الفيجواليزيشن here ما كانش fun part. It was actually very very important for us for debugging purposes to translate the information للexperts عشان هم ما لهمش علاقه بالفيجن، هم عايزين يشوفوا trees وتريز ما identify عليها البرونينج بوينتس، وهم يقولوا لنا البوينتس دي accurate ولا لا. وليتر محتاجين احنا نعمل السيميوليشن عشان الروبوت ارم ان احنا نشوف البوينتس دي فعلا هنقدر السيميوليتور ان هو you go into that particular point ب how much accuracy عشان يقدر يعمل البرونينج accurate. وده الطريق ولا فعلا على اللونج تيرم قدر ان هو يخلي الطريق still healthy والبروسيس ماشيه صح. فسو اللي حصل في الاول ان احنا كان عندنا مش عارفين نستخدم انهي سنسور، وذا ان احنا نستخدم لايدار. for those who don't know the lidar sensor بيبقى heavy وبيبقى expensive جدا، بس طبعا بيديك very high quality للسكاننج بتاعتك، بيديك 3D scanning very very good. On the other side we always واحنا بنشتغل في حاجه applied بنبقى بنفكر مش بس في الاكيورسي، ان احنا ازاي على اللونج ران ده يبقى فعلا سوليوشن برودكت. فلو انت معاك حاجه بتسكان بيها تقيله جدا وغاليه جدا، ده فعلا هيبقى مشروع يتنفذ ولا لا. فساعتها if you guys know the Kinect اللي كنا بنلعب بيه دوت في البيت كان لسه طالع، فقلنا اوكي why don't we try الكينكت. ما كانش غالي قوي، كان خفيف جدا. قلنا على اللونج تيرم لو احنا هنخلي الروبوت ارم يبقى يساعدنا في السكاننج فهيبقى سهل قوي للموفينج. فحاول بقى احنا نستخدم جهاز زي الكينكت فور اكزامبل، نستخدمه في ان احنا نعمل 3D scanning للتري، واحنا نعمل 3D reconstruction للتري. we know ان طبعا accuracy هتبقى مختلفه جدا عن اللايدار. اللايدار طبعا much more efficient، بس احنا ممكن بقى نطوع الالجوريثم بتاعت الكمبيوتر فيجن ان احنا نخليها هي more accurate بحيث انها compensate اللوس في الكواليتي بتاعت الايمجز دي. هل ده فعلا هينفع؟ لا، ما كناش نعرف، بس الاكسبيرمنتس اثبتت انه yes we can if we invest more in the computer vision algorithms we can actually try to mitigate الجاب ما بين اللايدار والكينكت، ونقدر maintain low cost flexible device flexible ways to scan and on the long run easy ان احنا نintegrate الكينكت مع الروبوت arm ويبقى more feasible solution and from the cost wise هيبقى اكيد less costly. فزي ما انتم عارفين انا هنا والطالب بتاعي كنا بنروح الاورشرز ونعمل سكاننج، وهو ماسك هو الكينكت ديفايس وانا كنت بعمل الجراوند تروث. ده بناخد انفورميشن طبعا من الفارمرز ومن الفاكولتي ممبرز اللي كنا بنكولابوريت معاهم جامد جدا في بردو او في بنسلفانيا، لان طبعا دول كانوا 2 big places اللي فيهم ابل اورشرز. نعرف منهم الاماكن انا ملوناها دي بالماركرز الريد والبلو دي اماكن انا الصح ان هم لازم الالجوريثم بتاعنا we call the ground truth يديتكت places دي as the points to be pruned. So we start from the beginning, collecting the data, ground truthing, even the sensors. Again, we publish this work in so many places. If you want to have an access to all of these resources, just go to the Robotic and Vision Lab on the School of Electrical Engineering, Purdue University. كل الماتيريالز كل الببليكيشن we put it in public for everyone so that we share all the success and the failures with all the students and all the researchers all over the world. So we collected the data. So what? Okay, computer vision lab دلوقتي كان دوره بقى بيلعب هنا جزء كبير. احنا كان هدفنا first ان احنا نحدد again what is our object. اول حاجه الريفرنس بوينت بتاعتنا ان احنا عايزين نحدد المين ترانك بتاع التري اللي هو الاحمر ده. ازاي ان احنا بعد ما صورنا وعملنا ال 3D موديل نقدر نقول للكمبيوتر focus on this part which is a trunk. So اللي احنا عملناه ان احنا استخدمنا math بقى a lot of 3D mathematical models. ازاي ان احنا نحول الصورة من صورة لنمبرز. we tried so many models whether we fit senders on this trunk. So we translate all this trunk into, as you know, mathematical equations. We also tried to use circles instead of the cylinders because we saw that the circles are actually going to be representing more variations أو النقلات في الtrunk بتاع التريز، لأن التريز ما هياش just straight، هي بتميل يمين وشمال وفيها curves. we found إن الcylinders ما كانش مديانا الflexibility دي. So when we fit circles to represent the trunk والbranches اللي coming from the tree, we had a very big improvement. And we also published it in I don't know if you guys will hear about this international conference on robotic applications. So that was a big deal. So الفاينل موديل اللي احنا استخدمناه so far هو كان احسن من الانيشال موديل. كان ان احنا we fit circles to represent the trunk and the branches because we need these numbers to represent each of this important information for us. So كان satisfactory model at this point. And then we wanted to go to phase 2 or phase 3 is that, okay, let's now visualize this model and validate this model. So we started building, as you can see, this is our initial trial to build our visualization, like 3D visualization, where we described each branch with an ID and then every circle بنعرف بالظبط هي قد ايه far من الروت بتاع التري وايه الراديوس بتاعها و every secondary trunk اللي هو جاي secondary branch which is coming from the base trunk اللي هم in red دول ازاي بنوصفه again ليه ID every part منه بنعرف هو قد ايه بعيدة عن المين body الانجل ما بين البرانش دوت والترانك. الانفورميشن دي مش راندوم، الانفورميشن دي فعلا اللي بيستخدموها الريسيرش from agriculture عشان والفارمرز علشان ياخدوا القرارات ان هم فعلا يعملوا pruning. فاحنا translated all those now into real rules وعملنا this visual representation so we can actually show and teach even new farmers how can they do the pruning. So this actually visualizer, it works, or it proved to be working in much more application than when we even decided to do it for debugging purposes. We publish it and then we even refine it now so that when you move the tree you can actually see it from every direction. In the right here دي التري اللي احنا كنا for example اخذنا طبعا tree في اللاب عشان نعمل some experiment في اللاب, and then when we rotate the tree on the right side you can actually see the 3D model here, and every model that you click on it, it gives you information, actually the numbers, the quantified information, its branch index, the circle, the angle, and it shows you الحاجة بتاعت التري دلوقتي before and after pruning if we apply the algorithm and we prune some of the branches. So far I think for the sake of time maybe I can just pause and see if there is other questions. So this is another application that we use heavily computer vision and we design our own features, and if you have any questions.
I don't think we have questions on this part, Doctor. Let me see.
Okay.
One question came in. Okay, we actually طيب محمد, can you type your ممكن تكتب السؤال بتاعك في الشات؟ طب ممكن محمد تكتب السؤال بتاعك في الشات؟ مي عايزة تسألي السؤال بتاعك اللي كنت سألتيه already ولا حاجة جديدة؟ طيب okay, so Mai is asking about the dataset size, Doctor. So for this project, يعني how big was the dataset that you needed to collect?
Okay, احنا we collected different trees. Huh? So I think we started, first of all, we had 2 trees on the lab that we had to do a lot of experience. ولما كنا بنروح بنعمل scanning كل مثلا مرة كنا كنا بنشتغل على 5 trees. So I would say we had a total of 10 trees from the orchard of Indiana, and we have another 10 from Pennsylvania.
Okay, but how many pictures did you
Pictures?
Yeah, the data size كانت قد ايه؟
I can't tell because احنا بنعمله ان احنا بنسكان التري بالكينكت with thousands and thousands of images, and then we do a 3D reconstruction from these images. So we have like I don't know, we have tons of images to construct the 3D model. So I don't know. What I can tell ان احنا استخدمنا كام tree because to scan a tree that is a lot of work, بس طول ما انت ماشيه بتستخدمي الكينكت سنسور عشان تكولكتي so many images, and you know الكينكت وانت طول ما انت ماشيه actually the video, so like many frames. I don't know, but that was not important for us because we just wanted to construct a high quality 3D model based on the scans that we collected. So that was not a big deal. We actually use a lot of them because احنا عارفين ان كان في فرق كبير قوي ما بين الكواليتي ما بين اللايدار وما بين الكينكت. فاحنا كان هدفنا ان احنا نستخدم الكينكت لان هو صغير وان هو سهل وان هو ارخص. ومش مهم خالص بالنسبه لنا ان احنا نستخدم a lot of frames to construct a high quality 3D model علشان we wanted to make sure that later on when we go to production, we use a device like Kinect that is small, less expensive, flexible, easy to integrate with the robot arm. So this was not an issue for us in this project ان احنا ناخد less images من السكانز. لا احنا كنا عاوزين actually make sure ان احنا ناخد as much as we can because we wanted to construct a high quality 3D model.
Okay, so the goal of the data set building part was to construct the 3D model, not to train the
high quality
algorithm?
Yeah, no. This is completely different. So in this application, our goal was actually how to construct a high quality 3D model. We don't care about the number of images. Because كان عندنا option تاني ناخد less images using the LiDAR with high quality image بس الجهاز كان كبير جدا. You cannot even move it and it was very expensive. So that's why we took this decision. Should we invest in a LiDAR, which will give us 1 or 3 images maybe and we're very, very good high quality, or we take the other route where we actually use a lot of intensive computer vision so we can mitigate the difference in the size and the price.
Okay, Doctor, I have more questions. Karim بيسأل, graph neural networks are gaining a lot of attention these days. Do you have any recommendations where to start and how it would affect computer vision in particular? It's a bit.
I know that, yeah, that's true. That's true. I haven't actually done much work with graph neural network, but I have so many colleagues working on that. That's not my point, so I can just go deep in that.
Do you think there is potential
yeah, of course,
for improvement using graph neural networks for this particular
Of course.
topic?
Yeah, I have so many colleagues who are working on that, but not me personally. So that's why I can't give you the right advice, but I know that I have so many colleagues in the lab even working on this, especially those who are working with the field of human computer interaction with the merge of computer vision. So or action recognition. So they do this a lot, but I did not do it by myself. So I cannot just go deep into that to give you my advice.
I think it's okay. كريم ممكن تكتب السؤال بتاعك برضو على Slack group. أنا عارفة إن أنت على Slack workspace, فممكن لو حد عنده input يعني share information و start a discussion there. طيب هاجر كان عندها برضو follow up question. Why did you construct a 3D model? Doesn't the Kinect get us RGBD images already?
Yeah, it gives us the RGBD, but it doesn't give you the 3D model.
We have to also do something.
So we use all these RGBD images to construct our 3D model. That's true. So this is our input. So we take all of these 3D models, all of these RGBD images, the depth images with the color information, so that we can construct our 3D model.
Okay. طيب في another question من محمد. I would like to ask about what is the latest technology regarding deep learning, distributed processing over CPUs. Do you have input on this, Doctor?
I don't actually use this a lot because my work is mainly applied work. So most of my work is mainly that we design our own work, not we make use of like off-the-shelf products. When we scale, so if we go into the scaling part, we just use the clouds and things like this. But we don't use a lot of deep learning because in our case, we have to make sure that our partners and our clients understand more about the why part, and all of this new deep learning parts miss this part. So when we deal with the United States Department of Agriculture or Faculty of Agriculture or the Department of Defense recently, they really wanted to know why the system is working, why it is not working. So we cannot just give them high accuracy and tell them this is working with high accuracy and they will be happy with that. So we have to make sure that we know the details. So we are more towards the traditional way rather than the new algorithms. بس لما بنكون بنعمل مثلا حاجات زي big challenges دي اللي بنستخدمها لان هي this is the fancy that can get us the latest accuracy with less time. But actually, we care more about the algorithms that we implement in the traditional school of computer vision.
Great, thank you so much, Doctor. I think we covered the questions اللي جات على chat. If you still have يعني more to the presentation, please go ahead.
Okay. So maybe last part قبل ما أمشي إن أنا maybe I talk to you more about what I'm doing right now. So as I mentioned في الأول إن أنا research دوت كان collaboration between me and Purdue. I was leading the lab for a couple of years and we worked in many projects. Currently, I am a professor in the Business Analytics department in the School of Economics and Business Administration in California, St. Mary's College of California. I am also the director of a graduate program. The program now is 12 years. We have scholarships, not many, like at least maybe 2 or 3 for those who have really high GPAs for international students. This is a STEM curriculum, which means for international students, that's really very good because they allow you to work in the United States for 2 years after you graduate. It's called OPT. So I wanted just to maybe give you an idea about some graduate programs that we are very proud of. I was part of creating 2 of them. One of them is the Business Analytics. It is again, all of them 12 months. All of them ends with a capstone project. And this capstone project must be with a company in the Bay Area here that you apply all what you have learned for the past 9 months into this project. It's a very good opportunity that companies can take internships for the students, give internships, or later on if they are very happy, you can even hire, or in general, a great experience for you. So maybe I will show you here some information for you. And again, if you are interested, you can always like contact me by email to assist you on the next steps. But I would love to share this kind of opportunity with the community of the students. So maybe I will talk about one program. This is called the Management and Technology. So this program is for all majors. All students can apply. Again, we work on 12 months. It's 1 year duration. And it has 4 modules. Every module is a quarter. I mean, quarter means 3 months here. So for example, it starts in the summer. You still have like two more weeks to apply for this year if you are interested. If not, then you can catch up again next year. For the summer, for example, they introduce you to the data analysis, how to analyze data, spreadsheet modeling, introduction to management economics, and financial and managerial accounting. This project aims at...
Do you mean to be sharing the screen?
I mean to be sharing my screen, but
okay.
I think I'm not, right?
You're not.
Okay. So البروجرام ده هدفه من الأول عشان تبقوا عارفين هو إن يطلع leadership skills. So it equips the student with leadership skills and the technology skills that they should apply in their capstone. So in the summer, for example, you learn something like data analysis, like spreadsheet modeling, managerial economics, financial and managerial accounting. وليه الحاجات دي؟ علشان النيتشر بتاع الكابستون بروجكت اللي هيجي لكم من كلاينت او بيجي للكلاينت at the end بيبقى دايما consulting data analysis project. بيبقوا محتاجين advice, data driven recommendation, where for example if they want to go for expanding internationally or they want to grow their business, what kind of technology they should be aware of, you should recommend, you should build for them, and also is this the right time or not. So this is why you need to look at a bigger scope. What does the economy looks like now? What is the financial and managerial accounting of the business right now? And also in the autumn, you learn skills like leadership skills. If you have an organization that you are working with, or you would like to create your own startup, how to manage your organization, how to lead your team. Of course, you need to know programming. So you need to learn program. Of course, you need to learn more about managerial finance so that you can give the advice complete from different perspectives, from the financial perspective, from the technology perspective. And then you learn about marketing. How can you do a lot of market research so that when you advise them to the next step, you understand exactly what's happening. So we educate you about marketing principles, data visualization, storytelling. If you have an amazing work and if you are not able to visualize this data and make a story to your client, which does not know anything about technology or business and doesn't even care. He just want to see the convincing results. So that's why we teach you data visualization. How your solution is outside of the box. So you learn about creativity and innovation, how you can communicate your results in a written way, reports, and oral way. So you learn about business communication. All of this is a preparation so that when you meet your client in the spring, you are prepared with this knowledge so that you can work on this consulting project. In addition, we also, this year, we knew that when you do a business or create your business, or you work with a consultation to provide the business, you need to be aware of the business ethics and business regulation. So that's why we added this new courses, business law and ethics, to educate you about this information so that when you give your data-driven recommendation at the end, it is taking into account this piece of information, so you are not lacking any part when you are giving this recommendation. Again, another important domain that's actually right now at the hype, supply chain analytics, so where they should allocate the resources. So this is an insight for you guys for one of the graduate program. We have another one called analytics. I also was part of this too, and the construction. And if you are interested, again, as I mentioned, we provide scholarships, not too much, but I think twice per program. So the program always start in at the end of the first week of, like I would say, July 6th or July 7th, something like this. You still have a couple of weeks. Now, into interested, you just reach out to me. You need to have a high GPA, of course. The process is not complicated. There are such many people, so many people that can help you with. Let me see if there is a website that I can share with you before you guys leave, that you can actually look at this program and other program. I think I put in the slide in one of my slides yesterday, but I want to share this with you.
Dr. Muhammad is asking if the program is available to attend remotely.
Yes, this year, at the first year, because of COVID-19, that most of these programs are remotely or what we call hybrid. So hybrid means that you have the opportunity to meet with your professors face-to-face if you want to, but that's not the normal format. So in the summer, it is going to be 100% online. In the autumn, it's going to be, I would say, 60% or 70% online, and all the lectures will be live and recorded. We don't know anything about the winter because no one knows. But what I know that this is something that people will be happy to work with you because it is open to international. We have many international students. Unfortunately, I haven't seen many from Egypt. But there are a lot from Asia, there are a lot from Japan, there are a lot from China. But I would love that I educate you about this opportunity. In 12 months, you can do a lot. It is an opportunity, especially in this pandemic. You don't need to care about visa. We usually work with you to get the visa, but in these days, even you don't need to worry about visa because everything is online at least until the end of this year. So I think this is an opportunity that I would love to share with you. I can follow up with Hagar or any one of you and send you some link if some of people are interested.
Doctor, is this the prerequisites are a bachelor's degree or the equivalent of a master's? What are the prerequisites?
It's a case-by-case basis, and ما نقدرش بس in management technology, for example, this was open to fresh grad as well as other people. But the GPA has to be high. You need to have a high GPA, like at least something like 3.5, not below that. Yeah, something like this. So, but the analytics, what they do is that sometimes they see if there is some kind of matching between the courses that you have, if you have master courses, and they can waive some courses for you. There is a limit, I think like 2 or 3 courses that they can be waived, but this happened in the case of the analytics.
So, Doctor,
but that's why yeah, أنا ممكن أبعت لكم اللينك
on the chat. Okay, we can share it on the chat عشان لو حد interested take note دلوقتي بدل ما.
اوكي خليني اشوف كده. انا متاكده ان انا حطيتها امبارح هنا في السلايد، بس ممكن اجيبها من الويب سايت. give me a second.
Sure, take your time. Okay everyone يعني لو في حد لسه عنده أي أسئلة ممكن يبعتها على الشات. احنا يعني almost done. I think Dr. Noha can take I think maybe like one more question. If not, we'll just end with Dr. Noha's announcement on the link. Okay. علاء عنده follow-up question يا دكتور. بيسأل what should I do in the upcoming days to improve myself at computer vision? Do you have general questions? Sorry, general advice?
طبعا our advice, I'm not sure if you guys are following Coursera or not, but this is one thing that I would highly encourage you. وأنا كمان كنت ببتدي الكارير بتاعي حتى وأنا مش ببتدي الكارير بتاعي. Coursera, you know Professor Andrew Ng. He is a professor here in Stanford. So this is the first thing I would highly recommend you, is that you make use of all of these resources, especially this course of Professor Andrew Ng from Stanford. You need to make sure that you really take this course. This is the first thing you can do. The second thing I would advise you, and always advise my students, if you really have some time that you can devote, is a Kaggle competition. Use it. Use it. This is a very good resource to build your resume, to connect you with the outside world. So many things, and connect with people outside. Sometimes فعلا بيبقوا الناس محتاجين some help. Let's reach out that I did this work and then I'm interested in your work. I don't care about, for example, ان انا اجي بس we can collaborate remotely. فاهم او فاهمه? This kind of things is really important. People are always, the researchers are really willing to collaborate and help, but you need to do your part and prepare yourself before you ask for something or before you collaborate, عشان لما تبقى رايح to contribute مش لسه تتعلم. ده بيفرق كتير معاك جدا وبيفرق مع اللي قدامك ان هو يبقى فعلا عاوز يموف معاك fast in this busy schedule. I would say highly recommended, and if you didn't take Andrew Ng course, please go for it. Second, do as much as you can in Kaggle. Either read forums or contribute in competition. Build your resume. I mean, build your resume means GitHub. Whenever you do a project, use your GitHub to post your code so people know that you really contributed. You can write code, high quality code. People can use it. Connect with outside researchers.
Okay, great. Thank you so much, Dr. على الادفايس and the great lecture. Dr. Noha بعتت اللينك بتاع الماسترز بروجرام على الشات، فلو حد interested please take note. واحنا ممكن برضو نأدت يعني نpromote it later on using our mailing list or on Slack. Thank you so much, Dr. Noha, for the great talk. I think كده احنا خلصنا ال questions. في بس announcement that I would like to make before everyone leaves. But okay, everyone is thank you, Kayla.
Thank you so much, guys, and I'm so happy. And then feel free to connect.
Thank you for the talk.
Thank you so much.
You're welcome. And this is my LinkedIn email if you would like to add.